Hello, I'm here. Let's see. We were working on 5.4, as I recall. Yeah, I should get through 5.4 and all of 5.5 today. So let me find where I was in this PowerPoint. I was getting ready to do number 10, it looks like. Does that sound right to you all? Problem number 10, my math lab number 10.
I don't think we finished the part 7. I think we need to find which graph that was. Maybe I'm wrong. I don't know.
Okay, maybe we didn't. All right, let me hit share screen. Share screen advanced. Okay. Nope, looks like I drew on it. It ended up being choice A. It had a vertical asymptote of, where's my pen? There we go. Remember the denominator, if you set that equal to 0, that'll find your asymptotes. So I subtracted over the 30, divided by 6, and got a vertical, I'll just abbreviate VA for vertical asymptote at -5, which would be right here. Also right here. This one was wrong and this one was wrong. They had them at +5. And then for the horizontal asymptote, you have to look at the degrees. Since the degree of the numerator was 1 and the degree of the denominator was 1, the horizontal asymptote will simply be this ratio right here, the ratio of the coefficients. So there'll be a horizontal one at 7/6, which is what, 1 1/6. And so I'm down to choice A and C at this point, and you can see that the horizontal asymptote here is above the x-axis on choice A, but on choice C, it was below the x-axis. So that one's out. So it ended up being choice A. I figured out based solely on the asymptotes. All right, so now let me switch my notes over to 10. Okay, follow the steps for graphing a rational function. So step 1 says, if needed, first write the given function as a single rational expression and then factor the numerator and the denominator. All right, the denominator is already factored. The numerator, however, can be unfoiled. It starts with an x squared, so it's got to be x and x. And then it ends with a -9, so it's either 1 times 9 or 3 times 3, and I need the pair that will give me the -8 in the middle. So it would have to be a +1 times a -9. Okay, so this is the answer I'm going to put, because that's all they wanted was find f of x in factored form. So that goes there. Remember, these have like 11 parts to them. 11 times as much fun. All right, next. What's the domain? And remember, the domain has to do with any value that x can be. But because I have an x plus 3 in the denominator, as far as denominators are concerned, that x plus 3 is never allowed to equal 0. So if I subtract the 3, x can never be 3. So it's going to be choice C. The domain would be the set of x such that x does not equal -3. Okay. And then my next slide, next question says, write f of x in lowest terms. If I went back to this slide where I wrote that down, x plus 1 times an x minus 7 all over an x plus 3. The only way this could be reduced is if you had an x plus 3 in the numerator to cancel out the x plus 3 in the denominator. But there isn't one. So that means this thing cannot be reduced. And my choice was f of x equals blank, or f of x is already in lowest terms. So it's going to be this one. I couldn't reduce the, what was it, x plus 1 times x minus 9 over an x plus 3. Nothing cancels. You have to cancel a complete binomial with another complete binomial. Okay, then you get another positive affirmation, and then it says find the intercepts. Remember, there could be x-intercepts and y-intercepts, or neither, or one or the other. So you just have to remember that y-intercepts, get a different color here. The y-intercept is when x is 0. So if I put 0, and you can put it in the original function up here, which was probably what I would do. This would be 0 squared minus 8 times 0 minus 9 over 0 plus 3. So I'd get a minus 9 over a 3, which would be a -3. Let's see, simplify your answers, type integers or fractions. Okay, they don't want it as an ordered pair. If they wanted it as an ordered pair, I would say 0, comma, -3, but they'll just want the -3. So the -3 is what I'm going to end up putting in. I just have to check to see if there's an x-intercept. Now for x-intercepts, that is when y is 0. That'd be blank, some number x, comma 0. So this one's a little tougher. I have to set x equal to 0, which I would do that right here. I would set x equal to 0 and solve for x. And of course, if you remember on Monday, I told you like the first step here would be clear out the fraction. So you'd multiply both sides by an x plus 3. And of course, over here, x plus 3 times a 0 would just be a 0. And then on the right, the x plus 3's cancel, but you'd still have the x plus 1 and the x minus 9. And those are your x-intercepts, which would be, you'd have to have x as a -1 for that one, and here x is a +9. So my choice is going to be A, because I have them. The graph has a y-intercept at -3, And my x-intercepts were -1, 9.
Those are our zeros as well, aren't they?
Yes,
Okay.
yes, all of those are considered the zeros. Those will tell you where vertical asymptotes are, and they'll also tell you where the graph either crosses or touches the x-axis. Which I think that's coming up. Let's see, next question. Come on. Uh-oh, what happened to my computer? There we go. Whew. Don't you hate it when that happens? Panic sets in. All right, determine the behavior of the graph at any x-intercepts. Okay, our x-intercepts were, that was what I just did in green. We had it down to the x plus 1 times x minus 9. Now, I have to look at these separately and look at their degrees. This one is x to the first, so that means it's going to cross at the x is equal to -1. And this one is also x to the first, so it's going to cross at x is equal to 9. So I am looking at choice B. Choice B is my answer. The graph will cross at both of those, at the -1 and the +9. It's going to cross there. Cross the graph. And then the next question says, determine the vertical asymptotes. That has to do with the denominator. The x plus 3, you would set it not equal to 0 to figure out what's not in the domain. When you set it equal to 0, you're figuring out your vertical asymptote because it wants an equation. Now there's only one vertical asymptote. The function has one vertical, and right here it does say type an equation. So you're going to type in here x is equal to -3. I remember vertical asymptote is really like one of those imaginary dashed lines. It's not really there, but it's there. You need to know where, it's like a boundary. Don't cross over this line. Okay, and now it says determine the behavior of the graph on either side of the vertical asymptote. Okay, so again, you're looking at the x plus 3, right? Because that determines the vertical asymptote. And you're looking at the degree. Now the degree is a 1. That is an odd degree. So remember, one end will be up and the other end will be down when it's odd. So on one side, it'll be approaching infinity and the other side -infinity. And I don't know which side is which just yet, but I at least know that. So when I read through all of these, it's going to be choice C. It approaches infinity on one side of the asymptote at x is equal to the -3 and -infinity on the other side. One end will be up, the other end will be going down on opposite sides. And then it says, determine any horizontal asymptotes. Now for this part, you have to look at the degrees of the numerator. The degree of the numerator is 2. The degree of the denominator is 1. 2 is greater than 1. When the degree of your numerator is greater than the degree of the denominator, then there will be no horizontal asymptote. That was one of those rules previously in this PowerPoint. So it's C. Next question is, however, is there an oblique one? Remember, if there's no horizontal, there could be or might not be an oblique one. And this is where the long division comes in. Okay, so I am going to take my denominator, which is the x plus 3. That's going to go out here. Here's the division bar. And then the numerator, it goes underneath the division bar. And then we're going to start by dividing. Okay, since this is an x plus 3, you just simply take the first term, x, and you divide it into x squared. So in my head, I'm thinking, what is x squared divided by x? Just x, right? Because this is x to the first, and this x cancels out one of those, leaving you with an x. That's what's going to go right here. But then what you have to do is multiply back times x times the x plus 3. And that's going to give you x times x is x squared. And x times 3 is a plus 3x. And then, of course, you're supposed to draw the line and subtract. Now you subtract vertically the columns. X squared minus x squared, that cancels each other out, that's gone. And then negative 8x, you're going to take your negative 8x minus that 3x. And of course, negative 8x minus 3 more x's would be a negative 11x. That's what's going to go right here. And then you drop down the negative 9 and divide again. And right here, you just have to do the first step because you're looking for a linear equation. It's an oblique, which means slanted line. And I've already got the first term. It's that green x. So now I'm going to take this x and divide it into negative 11x. And I'm thinking, what's negative 11x divided by x? Negative 11, because that guy cancels that guy. So I put the minus 11 right here. So it has one oblique asymptote. That's choice A. And they want the entire equation. In your problem or my work down here, this is what I get when I divide. The entire equation would be y equals the x minus 11. It's got to be in y equals mx plus b form. Questions on that? Okay, what's next? Still on number 10. Determine the points, if any, at which the graph of x or f intersects the horizontal or oblique asymptote. If you want to find where two functions intersect each other on a graph, you set them both equal to y. So you get y is equal to this, and the other one is y is equal to that. And then you just take the this and set it equal to the that. and solve for the x. And so my equation, which was this up here, this is my original function. The x squared minus 8x minus 9 over an x plus 3. And you're going to set it equal to the answer we got on the previous page, which was the x minus 11. Yuck. I got to solve that for x. Are you kidding me? Well, first things first, I don't want the fractions, so I'm going to multiply both sides by an x plus 3. So that over here on the left, the x plus 3 just cancels out. Which means over here I'm left with x squared minus 8x minus 9 equals, and over here I'm going to FOIL this. That's going to give me x squared. My outsides is positive 3x's and insides is negative 11. That's going to be negative 8x's. And last times last, negative 33. And at this point, something weird happens. When I first look at this, I'm like, x squared, that's a quadratic equation. I got to set it equal to 0. So I'm like, well, I need to get all my x squareds on one side. And when you subtract the x squareds on both sides, they both cancel out, which means, okay, it's not really quadratic, it's linear. So I got to get all my x's on one side. But when I add 8x to both sides, they cancel out too. And what I'm down to is negative 9 on the left equaling negative 33 on the right. But those aren't equal to each other. So that tells me that there is no point of intersection. That was what we were looking for here. We were looking to see where the horizontal or the oblique asymptote would intersect this graph, and it doesn't. So that would be choice C. There is no point at which the graph intersects either one of those, an oblique or horizontal asymptote. Okay. And now we're to this where it says, use the real zeros of the numerator and the denominator to divide the x-axis into intervals. Okay, so here's my x-axis, and my zeros were the negative 3, the negative 1, and the 9, right? I'm trying to remember what colors I used before, I don't know. This one right here, this was negative 3. That was one of my zeros. And then when I factored the numerator to be x plus 1 and x minus 9, oops, what did I just do? Yeah. This x was a negative 1 and this x was a positive 9. Those are my zeros. So I've got 3 zeros here. And they need to be, remember this is your x-axis, they need to be in numerical order, smallest to largest. So my negative 3 is here, my negative 1, and my 9. Now I'm going to get my highlighters out. This is divided into 1, 2, 3, and 4 intervals. And those intervals are, the pink would be from negative infinity up to the negative 3. The blue is negative 3 to negative 1. The green is negative 1 to 9. And the purple is 9 to infinity. And then I got to make a chart. And I have to pick one number in between all of those intervals and figure out whether the value comes out to be positive or negative, because then that will tell me whether it is above or below the x-axis. Capiche? All right, so I'm just gonna pull off what I did on my paper. For the pink one, between negative infinity and -3, I just grabbed -4. And you're actually gonna plug it into this function right here. You know, everywhere there's an x, I'll plug in a -4. And I'll just tell you that I got a -31. Since it's negative, I know that it's going to be below the x-axis. Then I went to the blue interval between -3 and -1. I just grabbed -2, which is the only whole number in there. Once again, I plugged it in here. I plugged and chugged, and I got 11. That is a positive, so it's going to be above the x-axis. Then I went to the green one. Between -1 and 9, oh yeah, I chose 0. I always choose 0 if I can. And when I chose the 0, I got -3 when I plugged and chugged. That is negative, so it's going to be below the x-axis. And then for the purple one, going from 9 to infinity, I just grabbed 10. And that one wasn't so pretty, but it came out to be 11/13, which is positive. So we're back to being above the x-axis. So choice A only says that things are above. Choice B says things are only below, but C gives me the option of above and below. So it's choice C. And for the above the x-axis, the two that were above was the blue was above and the purple was above. Okay, so in that I typed in this box right here, I said -3, -1, 9 infinity. All right. And then for below and below the x-axis, that was the pink and green. Pink and green were below. So in this box here, I typed in -infinity to -3, -1 to 9. All right, and now I have to take all that information and pick out the correct graph. Okay, remember that we had a vertical asymptote. I'm going to start with that first. We had a vertical at x equaled -3. So that takes out A because this looks like it's at x is +3. Same thing with B, that looks like x is equal to +3. This one right here looks like x is equal to -3, and so does this one. And now I need to look at my points. Let's see, or my table. From -infinity to -3, it should be below the x-axis. And that's got to be C, because, yeah, it's got to be choice C. -infinity to -3 was below x-axis. This one on choice D looks like it is partially below from here to here, but then from here to here, it's above it too. It's not that one. So it's C. And then one last question from 5.4. And this one says, which rational function has the given graph? Okay. I am going to look at there's two vertical asymptotes and only one horizontal. Now the horizontal asymptote is right here, and it is going through the y-axis at -2. So that has to be, if you have a horizontal asymptote, that is the ratio of your leading terms, which should have the same degree. If your numerator and your denominator have the same degree, there'll be a horizontal asymptote at whatever the ratio is. And they are all, get a different highlighter here. This is x squared to x squared, x squared to x squared, x squared to x squared, x squared to x squared. So they all have the same degree, but you're looking at the coefficients. This is 2/1, which is negative, so it could be A. This is 2/1, which is negative, so it could be B. This is 2/1, but that's positive, so it's not C. This is 2/1, but that's also positive, so it's not D. Which leaves me with my vertical asymptotes. And so this was the horizontal asymptote. My vertical asymptotes are at -2 and +2. X equals -2, X equals +2, which means I'd have to look at this denominator and this denominator and set them equal to 0 and factor, but x squared plus 4, this would be x squared equals -4, and that's imaginary. You can't take the square root of a -4, so B is out. This one, if I set it equal to 0 and then added over the 4 and then I square rooted, I'd get x is equal to ±2, so it's A. And that finishes 5.4. Questions, anybody? Before we do the next one? Anybody got anything? No. Okay. And 5.5. Okay. All right, here we go. In this section, we are going to solve polynomial inequalities and rational inequalities. And remember that when we say inequalities, we're talking about less than or equal to, greater than or equal to. We will start with the polynomial inequalities. All right. Solve it by graphing, they're saying. And they've already got it factored in factored form, and you'll notice that it says find where this polynomial is greater than 0. So they're basically asking you to find all the y coordinates that are greater than 0. That's what this is. This represents f of x, right? That's f of x, which is the same thing as y. So we're looking for points on the graph that all have a y coordinate of 0. And what we're looking for is all points above the x-axis. Remember, when you're in a graph, all of these up here, this is where your positive y's are. This is where your y's are greater than 0. So we're looking in quadrant 1 and 2. So here's the picture. You can see that, let's see, if you take the function, which was x plus 3 times an x minus 1 squared, and you set it equal to 0, you find the x-intercepts. This one would be -3, and this one would be x is 1. But this is x to the first, so it's going to cross at -3. X minus 1 to the second, if you took x minus 1 to the second and you FOILed that out, you'd get an x squared, which is even. So here it's going to touch. And if I took an x to the first, if you took an x to the first times an x to the second, you'd get an x to the third. This is a graph that would have a positive x to the third kind of a look to it. That means it's kind of got an SE shape, and the left end is down and the right end is up. It ends going upwards. It ends going on a positive note. So I can see that it's crossing at -3. Right here it crosses. It is touching. It's touching at -1, right? Does that little dip right here. And it has that basic S shape, right? It goes do-do-do, 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 right? It's got that S shape. Now, what we're trying to figure out is, where is that function greater than 0? Where is f of x greater than 0? And it would be in quadrants 1 and 2. So we're looking at all of this here. Now you'll notice it did not say equal to. Okay, so we're looking at from here down to here and up. However, that's 2 separate intervals because it says it has to be greater than 0. The first interval would be, and I got too damn many colors going on here. Let me erase this, sorry. We are looking from here to here, but there's no equal to. So if you go back to old school, it's as if this is an open circle and this is an open circle. You cannot include those. So the first interval that I'm looking at would be from -3 to the positive 1. That's right here. -3 to +1, but you'll notice there's parentheses on it. You can't include the -3 and the 1. And then the other part is this here, this side, which is from 1 to infinity. Now, had it been an equal to, if they had said f of x is greater than or equal to, I could just start at -3 and say, yeah, it goes from -3 to infinity. Because that would include the 2 points that actually sit right on the x-axis. So that would have been easier. But if you have to leave out those 2 points, you have to do 2 separate intervals. The first interval that goes in between those 2 points and the next interval that goes to infinity. I hope that made sense. There's not a whole lot of work on these. It's a lot of looking at it and going, okay, where am I looking? This one says, solve the inequality x to the 4th greater than x algebraically and graph the solution set. First things first, this has to be either, you want it to be where the 0 is on the right. You want it to look where you have f of x on the left, 0 on the right, and then in between would be either any one of those 4 inequalities in order for this to work properly. Because you want y on the left. Where is the y coordinate? Greater than 0. All right, so step 1 is write the inequality and a polynomial function on the left side and 0 on the right. So they did that. Then they factored. They pulled out an x. Oh my God, I got an x cubed minus 1. Lord, that involves a formula. Hopefully you won't have one of these in your homework. Oh, I didn't even look that deep into it. I'm just going to skim over that for a second. That's not nice. Anyway, when they're done factoring, they only got 2 x-intercepts, the 0 and the 1. This was to the first power and this was to the first power. So they're going to touch. So here's my x-axis. Let's see, this would be 0, this would be 1. Not touch, I'm sorry, they're going to cross. Now this is an x to the 4th original. But I see that there's 3 intervals. From -infinity to 0 is here. From 0 to 1, that's in here. And then the last interval is from 1 to infinity, which is here. Okay. Okay. I know it's supposed to cross at 0 and 1, but I don't know exactly what they're doing. So they did the whole table thing again. They picked numbers in those intervals, plugged and chugged to see if the result was a positive number or a negative number. And regardless of what that graph looked like, we know that, oops. Here's 0 and here's 1. We know that at -1, it's above the x-axis. So it's above the x-axis here. In between, it's below the x-axis. And between 1 and 8, it's above the x-axis. And we were looking for where f of x is greater than 0. So that would be the positive ones. So it would be above the x-axis ones. This one was from -infinity to 0, and this one was 1 to infinity. And here is their answer. You don't even really have to see what the graph looks like. You just need to know the value. So, and don't forget to use the union symbol in between separate intervals. Now that was a polynomial examples. Now there's a couple of rational ones. Rationals are those ugly fraction things. So I got this ugly mess of a fraction greater than or equal to 0. When they got done graphing the whole thing, it looks like this. And we're looking for where it was greater than or equal to 0. Now, greater than 0 means above the x-axis. So it is above the x-axis from here to here and all of this. That would be my greater than or equal to 0. Now this one has an equal to on it, so I get to use some brackets. For this first one, for this first one here, it goes between here and here up to there. So that is going to be from, I can't go over the vertical asymptote at -2. So it starts at -2 and goes to this point right here, which has an x coordinate of 1. Boop. But you can include it because it's an equal to union. And then we've got the other one over here, this one, which starts at the vertical asymptote of 2, but it's an asymptote, so you can't include it. And then it keeps going this way to infinity. And that's what they've written down here. Some of them will be giving you graphs to look at. Those are the easier ones. And then some will give you just equations where you have to figure some stuff out, make it a little more complicated. Like this one, they don't give me the graph, they just give me this. And they've got it less than or equal to 3, which is a problem. It's supposed to be less than or equal to 0. So they subtracted the 3 over, oh good God. They had to get a common denominator. Oh my God. Oh, that's nice. They had to get a common denominator, so you just take 3 and multiply top and bottom by this denominator. And then, of course, they also distributed the -3, which gave them all of this. And then the 3x squareds canceled out, and 13x minus 12x was 1x, and 9 and the minus 12 is this -3. And then they factored that to be x plus 2 squared. Okay, which means the vertical asymptote is at -2, right? This right here, vertical asymptote, -2. And then they divided the numerator, what was the numerator? Numerator was x minus 3, so there's a 0 at 3. So if you're looking at the x-axis, that's going to be 3 different intervals. Let's see, here's the -2, there's a vertical asymptote, and 3 would be the x-intercept. So you're looking at -infinity to -2, -2 to 3, and 3 to infinity, which is what they do on the next slide. And of course, they created a table. -infinity to -2, -2 to 3, and 3 to infinity. And they picked numbers, they plugged and chugged, and they found out the answers were negative, negative, and positive. And since we were looking for where, what were we doing? F of x is less than or equal to 0. Yeah, right here. We were looking for where f of x is less than or equal to 0. So we're looking for the negatives. Negative and negative. So this interval unioned with that interval, which is what they've got right here. Answer. Boy, they do a lot of writing. All right, so those are their examples. And now I've got 1, 2, 3, 4, 5, 6, 7. I did 8. There's 12 questions in your My Math Lab, and I picked 8, 4 that have graphs and 4 that do not, where you actually have to do tables and stuff. So we'll start with the graphs. Those are the easier ones. Part A. Part A wants to know, where is the function greater than 0? So we are looking for where it is above the x-axis. And that would be here and here. But since it is just greater than, I have to see as if these are open circles here. So for the first one, this one goes from 0 to 2, but doesn't include those. Open circle. Unioned with 4 to infinity. Boop. But then the next part says, where's f of x less than or equal to 0? And that is going to be below the x-axis. And below the x-axis is here and here. But because it is an equal to, I get to include this point and this point and this point, which means brackets. So the first one, this green one here, starts at negative infinity, which infinity always gets a parenthesis, goes up to the 2 and includes it, unioned with between the 2 and the 4. So this right here and this right here. And the other one was here and here. Do you see it? Okay. Next. Same deal. We're looking for where, let's see, I'm gonna use green and yellow on this one. We're looking for where f of x is greater than 0. So we want above the x-axis. This is above the x-axis, and this is above the x-axis. But because it's greater than, I need to see the 0 as an open circle. I cannot include that. So from left to right, my vertical asymptote right here is -2. That first interval gets close to -2 but doesn't touch it, goes up to the 0 but doesn't include it. And then you're going to union that with the next one over here, which gets close to 2 but doesn't touch it, and then goes to infinity. So this one here, that's this one. And this one over here, that's this one. And then the second part, we're looking for where the function is less than or equal to 0. This part is below the x-axis, and so is this part, but because it isn't equal to, I get to do a solid dot on this one. So my first one from here to here is from negative infinity up to the asymptote of -2, but don't include it, unioned with the 0, but I can actually include that. So solid dot means bracket, and then go to the 2, which is where the asymptote is, and you can't include asymptotes. So infinities and asymptotes get parentheses, but this 0, the origin right here, that is on the x-axis, which would be the equal to part. Any point on the x-axis is what your equal to part is covering. And then anything less than that would be any points down in quadrants 3 or 4. And all of the red is down in 3 or 4. Okay. Oh, now in this one, it says solve the inequality f of x is less than or equal to 0. All right, that's all they want. Where is this less than or equal to 0? So just looking at the picture from here to here, keep doing it to there. All of that is in quadrants 3 and 4, which is below the x-axis. It did say equal to, so I can include this point and this point. That is one big interval. If this had just said less than equal, I'd have to do 2 separate intervals, but it's got that equal to in it, so it's every point going from negative infinity up to the 4. This point right here is where it stops at 4, but you can include that. That's my answer. Now, just to play devil's advocate, if they had said f of x is just less than 0, no equal to, then you'd have to say negative infinity up to, this point is what, -1? To -1, don't include it, unioned with, on the other side of that -1, all the way up to the 4, but don't include it. This was just me being, well, what if mine had said less than? Then you cannot include the -1 and the 4. So it'd have to be in 2 intervals, going from negative infinity up to the -1. That's like to the left of it. And then from -1 to 4, which is to the right of the -1. And 18, once again, they're just giving you the picture. They want to know, where is the function less than 0? That means below the x-axis. This is less than 0. And just this part is less than 0. There is no equal to, so you cannot include the point that has the 2 on it. You have to see this as an open circle, and then you can have all of this. And then over here, you've got all of this, but those are asymptotes. You can't include the asymptotes either. So it's going from left to right. I'm starting down here at negative infinity. It comes along and then it curves alongside the asymptote, which is at 0. And then I'm going to union that. Then I'm going to jump to here, which is at +2. And then it moves along here and then runs along x is equal to 5, but never gets to 5. So parenthesis on that. Now those four all had pictures, so I'm just kind of like looking at them and saying, where is the graph below the x-axis, or where is the graph above the x-axis? And then I got to pay attention to the equal to, or is it not an equal to, because that's going to determine whether I can use brackets and what I can and cannot include. Now for the last four, they do not give me a picture. All they give me is the equation. And I'm gonna do something a little unorthodox on a couple of these, because to me, this makes more sense. Sometimes it makes more sense to do a table, but if I have a general idea of what this graph looks like, I can just do a quick sketch. And now I have a picture that I can just highlight like I did in questions 1 through 4. So this original problem, it's already greater than 0, all right? So I'm good there. When you look at all of this, if you took your x minus 9 and squared it, in that mesh, you would have an x squared. If I took all of this and squared it, I'd have an x squared, blah, 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 blah. And then if I multiply that times just the x, I end up with an x cubed, a positive x cubed. Positive x cubed graphs look something like that. Okay. And also, my x-intercepts are 9 and -6. So right now I'm like, okay, here's my x-axis. I know it's going to cross at, well, negative, it's going to touch at -6 and 9. Okay, touch or cross, or there'll be a point there. Those are my x-intercepts for sure. There is no asymptote on this because there's no denominator. And because I know that my graph looks like this, it's got to come up, intersect this, and I know it's intersecting. Let's see. This is x to the first. So that means it's going to cross there. The other one is x to the second. So that means it's going to touch. So it's crossing here, and then it's going to have to curve to come back down to the 9, but the 9 it has to touch, so it's going to do this. And then it's going to go back up again. I hope that makes sense. I know the basic shape, and then I know where its x-intercepts are, and then the degrees on those, the x plus 6 is to the first. So, a different color. Here's this one. This is to the first, so it's going to cross. So I know it's got to do something like this right there. But my other one, which was to the second power, that means it has to touch. So if it's already crossing, I know from this picture that it's down below the x-axis here, right? Going up, it's going to cross at 6, it's going to turn, come back down, but then at 9, it's going to touch it and go back up again. And here's where the touching happens, right here. So it looks linear over here and it looks parabolic over there. And now I need to highlight for where it is greater than 0. It's above the x-axis all of this. That is all above the x-axis. However, it is not an equal to. So as far as my x-axis is concerned, at the -6 and the 9, I am looking at two different intervals. This one here and this one here, going to infinity. So for my answer, it's going to be from -6 to -9, unioned with, not -9, April, +9, unioned with 9 to infinity. That is my answer that goes in this box right here. And that's how I thought that went through. Now, if you want to just, if you're not understanding the picture, you can create a table for yourself based on this picture over here. You know you're going to have the intervals. Of course, I'd have another interval here. Let's see. You'd have this interval here. So when you make your table, you're going to have from -infinity to -6, from -6 to 9, and from 9 to infinity. So I'd probably pick -7. In here, I'd definitely go with 0, and 9 to infinity, I'd pick 10. And then when you plug in, you chug. If you plug in the -7, I should get a negative answer. When I plug in the 0, I should get a positive. When I plug in the 10, I should get a positive value. And then I know that it's below and then above and above in those intervals. And you'd be looking for where it's positive. So the positive ones would be, you know, this one and this one, which is my two intervals there in this answer over here, as you can see. But like I said, I'm a visual learner, so I really see the graphs and I'm like, okay, I can highlight the part of the graph that's above the x-axis. The table is all mathematics. It's plugging and chugging and looking at values, and negative values means you're below the x-axis. Positive values mean you're above the x-axis, but they both work. They're both valid methods. Okay, let's try another one. Okay, now this one, I've got it greater than or equal, or sorry, less than or equal to 0, but it's not in factored form. So I have to take this and factor out, an x squared, which leaves me with an x minus 9. So I've got two x-intercepts. This one's at 0. This one's at 9. So on my x-axis, it's gonna, this is 0, this is 9. I can see up here that it is a positive x cubed, so it's gonna have this kind of a shape again, just like the last one. Except this time, the x equal to 0 is an x squared. So this one, since that's even, it's going to touch there. And then this one, since it's x to the invisible 1, that's odd. So it's going to cross. So on this one, my graph has to touch. It's got to have this shape, which means I'm touching here, right there. And then crossing, this part goes up, so it's going to go up and cross at 9 like that. But the part that I'm looking at is less than 0. So anything below the x-axis, this is all the parts below the x-axis. However, there's no equal to on that. So I'm looking at an open circle here, can't include it, and an open circle here, can't include it. So I've got two definite intervals here. This one here, and this one here. Those are my answers are going to be. So this is from -infinity up to 0, but don't include it. And then this is between 0 and 9, and don't include it. That's this interval. That's this interval. Again, if I picked a number between -infinity and 0, like -1, and I plug it into this function, the x cubed minus 9x squared, I'm going to get a negative value, which means I'm below the x-axis. If I pick something between 0 and 9, like +1, and I plug it in, I'll also get a negative value. But if I pick something bigger than 9, like 10, and I plug it in, I'm going to get a positive value. We're looking for less than 0. We want negative values if you're doing the chart. Okay. Now this one is already factored. Thank you very much. But this time it's looking for less than or equal to. So here's my x-axis. There are 3 x-intercepts. This one right here would be 3. This one would be 4. This one would be 6. So this, they're in the right order too. 3, 4, 6. And it's x to the first, x to the first, x to the first, x to the first. All are going to cross. And because it's an x times an x times an x, that's going to be a positive x cubed. So it's going to have this shape. So this one's going to cross, curve, cross, curve, cross. And we're looking for less than or equal to. So this is less than, and include that dot. And this is less than, which would include these dots. So my intervals are, the first one goes from -infinity up to 3, unioned with the 4 to 6. Now, if you make a chart, you'd be dividing it into 1, 2, 3, 4 intervals.
Where would the brackets be? Those would be brackets, wouldn't they?
Oh, yes. Crap. Thank you. Because we're including them, April. Hello. Yes. Thank you, thank you, thank you. Is that James?
Yes.
Cool. If you were going to do a table, you'd have to go from -infinity to 3, from 3 to 4, from 4 to 6, and 6 to infinity, and then pick numbers and plug and chug and see where the answers are. And of course, it should be negative here, positive there, negative here, positive there. And you'd still be going with the negative ones, which is those. All right, I got one last example and I am out of time. And this one actually is probably going to take me about 5 minutes to do it because I have to do tables on this one because this is not an x cubed. This one's a crazy looking thing. So definitely gonna have to do a table. So I will save this last problem for next time. It is the hardest problem in here, but you should be able to go ahead and do almost all of this section on the homework. And you can try to give this one a crack if you want, but I'll have to wait till Monday to do it. So I'm gonna stop sharing and ask if anybody has any questions about anything. I'm looking rough today.
So 5-5 is due this Sunday?
Yeah, I'll have to extend 5-5,
Gotcha.
but for that one problem. but you can go ahead and I would go ahead and work on as much of it as you can, what I've got done. So, all righty. Ciao. Have a great weekend.
Thank you. Bye.
Bye.